Hello, Senior 5 and Senior 6 students out there. Welcome to the eMath Learning Platform by Peter Ekaja. I am going to take you through one of the topics in pure mathematics, and that is going to be the binomial theorem of any index. My YouTube channel is eMath Learning Platform, and the email address is ekajapeter@gmail.com. In case of any questions or clarifications, my contact details are here below, with the first one being available on WhatsApp. So let's look at the binomial theorem of any index. Now, we are going to have a formula, which formula is clearly quoted in a mathematical book, what we so call the log table. It is clearly stated there, and so whenever you're in an examination, you are very free to ask for it, and you will really find this formula clearly stated there. So this is the formula for binomial theorem for any index. Now, should you realize we have 1 plus x power n equals to 1 plus nx plus n into n minus 1x squared out of 2 factorial. This symbol you see here is what we call factorial. Plus n into n minus 1 into n minus 2 x cubed out of 3 factorial, and so on. Now, when you're given an expansion to make, you're simply going to first restrict yourself to the following. In most cases, after expanding, they will always ask you to state the range of values of x for which your expansion is valid. How do we state it? For example, for this specific expansion, what you do if you're to state the range of values of x for which it is valid, you simply place x between -1 and +1. Now, writing -1 less x less 1 can also be written as magnitude of x less than 1. And remember, when we say -1 is less x and x is less 1, it means x is between -1 and 1. So let's look at some examples. Number 1, expand 1 minus 3x power a third as far as the term in x cubed, full stop. Then use your expansion to find the cube root of 24 correct to 3 decimal places. What do we do? In the first stage, compare this that we have in the bracket with what we have in our formula. So you realize we have 1 which compares to this 1. Then this x this time round compares with -3x. So it means in this very formula, we are going to substitute for x as -3x. So x will be substituted in the formula as -3x. What I'm trying to say is wherever you see x, you will simply substitute -3x. Then when you compare the powers, we have power n, and here we have power 1 out of 3, which is a third. So it means even wherever you see n in the formula, you will simply put your a third. And finally, press your calculator and you will come up with the expansion which will remain in terms of x. Let's look at the solution for that. So we are saying from the binomial theorem, we have just quoted the formula as it is in the introduction. And we said this formula may not carry marks, especially in the Ugandan system of examination, because we shall always assume that you copied this formula from the mathematical table. So whether you state it or not, it may not be very, very necessary, but for simplicity and to help you follow up very well, make sure you state it such that the substitution can be easy for you. Now let's look at the next step to that. So the next step is simply the substitution. So we are simply substituting. Wherever there is n, we said you're going to put a third, and wherever there is x, you put -3x in the above formula that we have just talked about. So that is what has happened here. Then the next step is you're going to just multiply now a third multiplied by -3. So you'll get -x. Then if you get a third into a third minus 1, times -3 squared out of 2 factorial, you will come up with -1. Then you multiply it by your x squared. Remember, this x here is also affected by the square. Should you do the same here, you will also get the same thing. So after making our substitution perfectly, it will give us the whole of this. So if you press your calculator carefully, only making sure you compute the constants and combine them together, you will come up with this answer. So now it means our expansion of 1 minus 3x power a third is just as good as 1 minus x squared minus 5 out of 3x cubed. But remember, the question continued and asked us to find the cube root of 24. How do we continue with that? So what you're going to do is to first break down 24 as a difference of 27 and 3. We can all see that 27 minus 3 is actually the same as 24. Why have we chosen 27 specifically? It's because we know 27 actually has a perfect cube root. So should we try to break down this expansion here? You pull out 27, and after pulling out 27, remember it has to move out with a power. And so this bracket also maintains the same power. So it means you will have 27 out, but power a third. Then you remain with the 1 minus 3 out of 27. But remember, 3 out of 27 is as good as 1 over 9. But still the bracket maintains its power. Remember, that is some good and correct mathematics that you should have to agree with. Pull out the 27, it moves out with the power also. And whatever remains in the bracket still maintains the same power. So from that point, you will come up with something of this kind. So we shall have 3 into 1 minus 1 over 9 power a third. Now, why have we expressed it in this form? We have expressed it in this form such that we can now easily compare our bracket that we have here, power a third, with our bracket that we had here with power a third. So should you make the comparison, it means 1 minus 3x is actually equal to 1 minus 1 out of 9. So that is the next step that we are going to go for. So we are simply comparing the two brackets such that our negative 3x gives us negative 1 out of 9, and therefore by dividing through by negative 3, we shall come up with the value of x as 1 out of 27. Now remember, we have kept the 3, but this 3 has to be brought in back later, especially when you're doing the substitution. Let's look at that. So we are now saying cube root of 24, which is also as good as 24 power a third, is as good as 3 into, this 3 is the 3 we kept here, into, now we have this very expansion that we came up with, this one here. Then you substitute the value of x that you obtained, 1 out of 27. Remember, 1 out of 27 lies within our range. And for this case, if you were to find the range within which our expansion lies, it will actually lie between negative a third and positive a third. So this value lies between negative a third and positive a third. So we do the substitution, and at this stage, you simply press your calculator and get the answer. But remember, they instructed you to use 3 significant figures. So you have to make sure you round off your answer to 3 significant figures. So that was our number 1. Let's look at the next number. So number 2 says expand 1 minus 5x power a third in assigning powers of x as far as determine x cubed. By substituting x equals to 1 out of 27, evaluate the cube root of 22, correct to 4 significant figures. State also the range of values of x for which the expansion is valid. Very interesting. Let's look at the solution for this. So our formula is going to still be the same. We shall apply it This is still our formula that we started with, and we said it is in a mathematical table, clearly quoted, and you are allowed to ask for the mathematical table in case of an exam. So we're going to compare again. When you compare this again with what we have been given, you realize n corresponds to a third, but x that we have here corresponds to negative 5x. So it means wherever you see x, we shall substitute negative 5x, and wherever you see n, we shall substitute a third. So that is what happened in this expression. And remember, they told you to remain at x cubed. That is why we have ended here at x cubed. From that point, simply work out all these constants and come up with your expansion in terms of x. And that is what will be your answer. So we have just expanded. But remember, they told us by substituting x equals to 1 out of 27, we evaluate this correct to 4 significant figures. So what are we going to do? Since they have told us you substitute, they're saying by substituting, if they have given you the value already, unlike in the previous case where they didn't give it to us, you are going to substitute both on the left-hand side and the right-hand side. That is going to be the simplest way of going through it. Substitute it on the left-hand side of this and also substitute it on the right-hand side of your expansion. So that will give us the next step that we have as this. So you can easily see we have made the substitution. And now the next thing is press your calculator, come up with this and make sure you have your answer in terms of a fraction. Have your answer in terms of a fraction and also press this and come up with your answer. Now you will realize that when you do so, you will come up with 22 out of 27 on the left hand side, power a third, and on the right hand side you will have some answer of this kind. I have rounded off to around 6 decimal places at this level because we are not yet at the final answer. Now next to this, we need to understand that a cube root of 22 out of 27 is as good as a cube root of 22 divided by cube root of 27. So we are interested in the cube root of 22. So it means we make it the subject. It means we are going to multiply both sides by the cube root of 27, and that is going to be our next step. So should you do so, cube root of 27 is 3, multiplied by this value, you will come up with this answer. And then you round it off to the given number of significant figures, basing on the instruction from the question. So that gives us our answer for that. They also asked for the range of validity. Now, when you go back to what we had, this is what we have. And if you to compare it with this, we said for this expansion, for it is valid when x is between -1 and +1. So it means for this expansion to also be valid, it will only be valid if -5x is between -1 and +1. And that is exactly what I did to come up with this step that we are yet to see, this one here. So I say range for validity, we're going to say -1 less -5x less 1. And if you divide through by -5, the simple mathematics will tell you that actually you get -1/3 less x less 1 out of 5. Or it can also be written as magnitude of x less than 1/5. This represents this. So any of the forms can be written, but do not write both in an examination. So that is going to be the range for validity. In case of any clarification, my contact information is clearly stated on our first page. Let's look at the next question now. It says, by using the binomial theorem, expand 8 minus 24x power 2 out of 3 as far as the fourth term. Hence find 4 power 2 out of 3 to 1 decimal place. This is kind of interesting. Now, what do you realize? Again, the formula comes back. The same formula is going to be applied. But remember, in this formula, we have 1 plus x. So for us to create a 1 here, you simply have to pull out the 8. And once you pull out the 8, like we said, the mathematics becomes correct only and only when it moves out with the power. but whatever remains in the bracket will also maintain the power. So it will be 1 minus 24 out of 8. Why are we dividing by 8? It's because you pulled out 8 out of this bracket. So once you pull out this 8 out of this bracket, this term here that remains inside will be divided by what you've pulled out. And in this case, you pulled out 8, and that is why we have divided by 8. The power is maintained. And if you press this in your calculator, 8 power 2/3, it will give you 4. And so you shall have 4 into 1 minus 3 power 2 out of 3. So now to expand this, we shall simply first expand 1 minus 3x power 2 out of 3, then finally multiply our expansion by 4 later. So that is what I've done. 1 minus 3x power 2 out of 3. If you expand it, you get all this. And after substituting and pressing your calculator carefully, you will come up with the final answer for only 1 minus 3x power 2/3 as 1 minus 2x minus x squared minus 4/3 x cubed. Then from this point, since we're interested in this expansion here, we now multiply by the 4 we had kept earlier around at this stage. So we multiply this expansion by 4. And when you do so, you will surely have 4 minus 8x minus 4x squared minus 16 out of 3 x cubed as our final answer for the expansion. There is a hence part. So they also want us to find 4 power 2 out of 3. What do we do? So at this point, we are basically going to use the comparison approach. So we compare 8 minus 24x power 2 out of 3 with 4 power 2 out of 3. Should you compare, it means whatever we have in the bracket here is equal to 4. And if you do so, you will try to make x the subject and finally realize that x will be a sixth. So the value of x is a sixth. It means it is the value we are going to substitute in our expansion. So we now simply say 4 power 2 out of 3 is equals to 4 minus 8 into 1 out of 6 minus 4 into 1 out of 6 but squared minus 16 out of 3 into 1 out of 6 but cubed. This is obtained from our final answer for the expansion. If you realized we got something like this. This is the answer we got. So we have just basically substituted in this expansion. Which value have we substituted? We have substituted for 1 over 6. So that is how that came about. So now, if you press your calculator carefully, you will get 2.53083, and you have to round off to 1 decimal place because it is what we were told. You have to round off to 1 decimal place, and that gives us 2.5. So dear students, after these 3 examples, I now expect you to also try out a few questions to check out whether you really got the concept or not. In case you have any queries or any kind of clarification that you need, feel free to check on me either by email or even by contact. You can check on me on WhatsApp and we see how to help each other. Otherwise, let's look at this exercise now. So I'm saying number 1 is given by that. So you will just simply look at this exercise, and the number 2 is that. Then finally our number 3 is the whole of that. So you try out these numbers. We shall continue right from this point in the next tutorial and see how to develop more and more. How best can you use this video? Play and pause. That is if you're on YouTube. Play and pause, and once you pause, you will be able to write down something in case you needed to. Otherwise, thank you very much. God bless you. Remember to visit my YouTube channel, it is eMath Learning Platform, and subscribe to receive continuous updates whenever I upload new content. Have the best of your day. Bye bye.